So what we're going to do is we're going to start a brand new topic that covers polynomials. And so we'll start off with just kind of what is a polynomial, like just certain basics. But basically what a polynomial is just, let's see if I can write on here. It's just one or more terms with positive exponents. Now, I'm giving you a very generic definition of polynomials. Like if you went to a mathematics book and you look this, it'd probably be more like very formal. I'm just trying to give you what you're going to need to be able, just to give you a basic understanding of what a polynomial is. And really, I'll just, in here, I'll put what an example is. But like if I did 15x squared plus x plus 5. That's a polynomial. It has multiple terms in it. We'll talk about what terms are and things like that. One of the things where it says characteristics, I was debating what should we list right here. Things that, what is not or what isn't a polynomial. You can't divide by a variable. Okay, so if you divide by, and I'm going to do some of the highlights, some of the things that kind of stand out. You can't have radicals of variables. And to me, those are the two main things, and this kind of leads into examples of what isn't a polynomial. So like when you're doing the delta math, if you have something like 7 divided by x plus 5 x, y, that's not a polynomial because you're dividing by x. You cannot divide by a variable. Another thing that you cannot have is you cannot take the square root of a variable. Now you can take the square root of a number. So if I had 7 square root of x plus y, that's not a polynomial because you're taking the square root of x. So right off the bat, that doesn't make it. Another thing that what isn't a polynomial, you cannot do like if I did 7x to the negative 2. You cannot have a negative exponent. Those to me, when I went through the delta math, those were the 3 things that I noticed the most. You cannot have x in the bottom, any variable, a, b, c, whatever the variable is, you can't take the square root and you can't have a negative. So what does look like a correct polynomial? So you can take the square root of a number. You can have a number just by itself. The number 2, that's a polynomial. Well, it's a type of a polynomial. It's called a monomial, and we'll get into all that. Another example would be like 2 minus x. It can be simple like that. It can also be super complicated. Now, you can take the square root of a number. It just cannot be of the polynomial, the variable. You'll see the difference. You can have to the power of 10. You can have whatever power. It can be big. You can do plus 7xy. You can have 2 variables being multiplied together. Minus, I don't know, let's do 10x to the 5th. So those are 3 examples. They can come in so many forms, and so on and so on. But again, what you'll need to know delta math, a lot of it is basic. There's no solving. It'll just ask you, is this a polynomial? Yes or no. And you're just going to put yes or no as you're going through the delta math. And again, things to look for, you cannot divide by a variable, you cannot take the square root, and you cannot have a negative exponent. Now you can have a negative exponent on a number. Okay, so if I had, let's say I did 7 to the negative 2, that's okay. It just can't be the variable. Okay, it just cannot be the variable. So that's what that had. So what I'm going to do for this bottom part of the notes, I'm going to use this down here. I'm going to highlight it in yellow. If you kind of notice that right there. I'm going to use that example to answer these questions in these boxes. I'm probably not going to do all the examples. I just want to give you a feel for, how a polynomial works. A polynomial, when I ask about terms, everything that's separated by a plus or a minus sign is a term. So if you look at this right here, this one has Let me move this up a little bit. This one has 1, 2, 3, 4 terms. So this one has 4 terms. And again, I'm going to use that one down there as an example. If it's separated by a plus or a minus, it's a term. Whether it has a variable or not, it doesn't matter. So this one has 4 terms. The coefficients are the numbers that are multiplied to the variable. So your coefficients would be the 15, the 3, and the -2. All those are coefficients. The 1 is not a coefficient because it doesn't have a variable tied to it. So it has 3 coefficients. Does that make sense? This number right here, the 1 that doesn't have a variable, that's called your constant. So if it doesn't have a variable, it's just called a constant. So the variable would be 1. Now, it's asking for the leading term. One of the sections of your homework is going to ask you to write polynomials in standard form. So when you look at a polynomial, what you're going to do is you're going to look for the highest power, the biggest degree. That's the term that leads, controls that polynomial. So when you look at this polynomial right here, the biggest power or exponent is the number 5. If you see right here, that's your biggest power. You have to rewrite it in standard form. So the way you rewrite it is you put the leading coefficient first, the biggest power, and then you go in descending order from largest to smallest. So this one is your biggest one. So I'm going to put that one first. So 3x to the 5th. Then you're going to put the second highest degree, which is going to be to the power. Let me erase this, or I'll leave it like that. But x to the 4th would be the second largest. So then I'm going to put plus 15x to the 4th. And then the next smallest would be this one here. So minus 2x and then plus 1. Constants will always be last. But do you guys notice how the biggest degrees will dominate? Not the 15 or the 3, but the powers. So the power of 5, the power of 4, you go in descending order. If there was power of 3, that would have gone next. The power of 2 would have gone after that, so on and so on. If you have a power of 10 and that's the biggest one, that's your leading term, your leading coefficient. That's the boss. So this one, when it's asking for the leading term, the 3x to the 5th, all of that is your leading term. So the leading term would be 3x to the power of 5. The leading coefficient is the number that's being multiplied to the variable, which would be the 3. Okay, so 3x to the 5th is the boss. Everybody follows that person. And then the highest degree would be to the 5th power. I'm going to give you these names because you're going to have to know these on Delta Math. We'll write those down here in just a little bit. That just gives you an overview and of how that works on those. So far, you guys say it's not too bad. It's just recognizing, right? It's not like you're having to solve for X and do all this complicated stuff. You're pretty much just, you're just trying to identify parts of a polynomial. Okay. All right. So I'm going to go ahead and move on. This is being recorded, so if I'm going too fast or you miss something, you can always go back and watch it on this one. So real quick, guys, you do need this part. Should we go to the next page? If you're at home, if you don't have this printed out, I would write this down, though. These are going to be the names. And also here at the top, we name polynomials by the leading term, by the leading coefficient. Roman, there's a copy of the notes in the front. So we name polynomials according to the leading. No, hold on, let me take that back. By the highest degree. That just means the power. So when you look at this right here, if it doesn't have any powers, so if it just has if the highest power is 0, then we just call it a constant. If the highest power is 1, we call it linear. I think you have to know these for delta math. I just kind of vaguely went over them a little bit, but I think you have to do like linear. If it's the highest power is 1, it's linear. If the highest power is 2, it's called quadratic. If the highest power is 3, it's called cubic. If the highest power is 4, it's called quartic. And if the highest power is 5, it's called quintic. That's a Q, it's Quintic. Quintic. Let me make that a little bigger. Oop. Make that bigger. So it's constant, linear, quadratic, cubic, quartic, quintic. So like when you start doing, this is the delta math, sometimes it can be annoying. It has like 5 drop-down boxes and you're gonna have to know the terminology for those. If it's greater than 5, we'll just say, now I can't speak for delta math. I didn't do enough examples. We'll just say like nth degree. So if it's like a 10, the power of 10, we'll just call it a 10th degree polynomial. We'll just do that. If it only has one term, it's called a monomial. So right next to it, what I'll do is I'm going to list an example. So that could just be like 5x. That's an example. So what I'm doing is I'm going to put an example over here to the, let's make another column to see what does it look like. If it has 2 terms, it's called a binomial. So that would be something like x squared minus 10. That would be an example of that. A trinomial means that it has 3 terms. So trinomial would be something like, I don't know, 5x to the 4th plus 2x minus y. That's a trinomial because it has 3 terms. If it's greater than 4, we'll just call it a polynomial. On those. These are words that you're going to need to know, like when you're going through the delta math and you do your drop down and stuff like that. Those are some of the terms you'll have. So I'll leave it here for a little bit. You can want to take a picture of it, or if you want to write it down, however you prefer. Number 5, this one, let me spell it. It's quintic, it's Q-U, quintic. Q-U, you're welcome. Okay, so what I want you to do just real quick. Again, if you don't have a copy of this one at home, on a piece of paper, or just do it mentally. Just kind of go through here, do this section right here. See how well you think you understand what we just went over. Just do the first one. If I feel like you guys understand it, then we'll move on to the adding, subtracting, and we'll finish off with that. Okay. See if you can do that one. I'm going to add one thing on here. Rewrite it in the correct form. So rewrite standard form. You can do it right here because that's not the correct form right there. I mean, if you're going to eat, you got to chew with your mask on. if you can eat in the classroom. Yeah. Thank you. I'll give you one more minute to do the first one. If you finish and you just want to try the others, you can. But I'm only going to go over the first one. All right. So checking your answer for the very first one, you want to put the leading coefficient first. So the biggest power is the 4x to the 4. That's the boss. And the way you can tell is you look at the power, the biggest power dominates. So it should be 4x to the 4th goes first. The second would be the 5x cubed. The power of 3 dominates, not the coefficient. The number in the front has nothing to do with it. The 3 has a bigger power than the 5, actually. The 4 has a bigger power than this 4 right here. And then you put minus 2x because it's to the first power. Even though we don't see it, that has to the 4th power. And then the last one, the constant goes last with the 5. So that would be the correct order. You do have some problems in Delta Math where you have to rewrite them in correct order. Pretty easy stuff. You don't have to solve or anything like that. When it's asking for the degree, it's asking for the highest power. So the highest power would be the 4. So this would be a 4th degree polynomial. So the 4th degree is going to dominate the thing. Even though it has a power of 3, it kind of takes over. Powers are very, very influential. When you look at the number of terms, this one has 4 terms. It has, so if I look up here, this has 1, 2, 3, 4. Anything separated by a plus or a minus is what tells you how many terms you got. The way you name it by the degree, the highest degree. So you look over here, you see this 4th degree. So you go back to that list. So the name is going to be quartic. It's going to be a quartic. Okay, that's how you would name it. And so on and so on. These are pretty, like, I'm not going to go through all these, but this would be a quintic. I will talk about this one right here. This one right here has a power of 1. So that's a linear. So that would be a linear. Okay, so that would be just to kind of FYI, this would be a quintic. If Delta Math does give you, I think I misspelled that. If Delta Math gives you just a number by itself, like if it gives you, let's say like it gives you just like a 5, it has no variable. This would be called a constant because it has no variable. Technically, it does have one. If I put x to the power of 0, that would be your, it dominates. So if it's by itself, it has x to the power of 0 means that it's not there. Oh, actually, I did that wrong. it would actually go here, x to the power to the 0. You don't see it there, but it's understood that it's there. The 0 means that the x has no influence. It's actually to the power of 0 is just 1. But I'll go ahead and take that off. Just wanted to point that out. So if they give you something by itself like this, no variable, it's just a constant. So just that kind of gives you an overview. I would say about 75% of your homework is over this stuff, which is pretty easy. It's not too bad. You are going to have some operational stuff. The second part of your homework, you're going to do what's called adding, subtracting. Guys, it's pretty easy. I mean, you're just going to add terms. You're just going to combine like terms. Remember when I did this in Algebra 1, most of my students could do it. You just combine like terms. So if there's nothing, if it doesn't have a coefficient, it's understood that it's a 1. This is on the last page of your notes, I believe. What you do here is you're just going to line up like terms. This term lines up with this one. Those are like terms. The 3x goes with the 5x. And then lastly, the 2 goes with the 5. So really all you're doing is you're just going to combine these two, those two, those two. If it doesn't have anything to combine it with, you just don't combine, you just leave it alone. So I'm going to do this mentally. So I'm going to do it in my head. So I'm going to do 2x squared plus 1x squared gives you 3x squared. What I like to do when I add these, I like to cross them out like this. I just cross them out, easy stuff. When I do the 3x minus 5x, it's just like combining integers. So you do 3x minus 5x is negative 2x. Cross them out. And then the last thing would just be 2 minus 5, which is just negative 3. This is, you're not solving it. You're not going to tell me x is equal to anything. You're just simplifying, condensing. You're just combining like terms. If you're at home and you want to, when you're doing these, if you want to add them together, I think, let me see, like this. You want to do it like this. You can line them up. You can just put them on top of each other. So all that matters here, like I'll come back to that example right before because it's very important. Yes. Oh. So when you're doing this, if you want to line them up like this on top of each other, you can do that. Remember, all that matters is that their terms are the same. So we're going to combine these two because they both have the same terms, the same variables, that is. So all you do here is you just add 4 plus 6. So the correct answer for this one is 10 x squared y squared. You do not add the exponents. You're just adding. Okay, you don't add the exponent because they have the same x. When I look at the second one, notice how they both have xy. They're like terms. You only add the coefficients. So then that would be 8 plus 5 gives you 13. Do not mess with the variables. You leave them alone. Does that make sense? Okay. Oh, there's a question. Yes. I will go back to let me just finish this one and I'll go back to the previous page. And then notice that on the last one, these two here, the 3's are going to cancel out. Negative 3 plus 3, that's just 0. So that's just 0. So you just leave it like that. So this would be the correct answer on those. It's just adding coefficients. That's it. Let me go back real quick. Somebody did ask to go back. Was it right here that you needed to take a picture of, or what? Or was it before that? And what I can do is I can put it here real quick if you need to take a picture of this one. So if you want to take a picture, you kind of get all of it right there. You can always zoom in your pictures, right? Okay, so let me continue. I know it's a lot. It's not really like too difficult. So just to finish off right here real quick, if you guys want to try this one here, you don't have, so I taught you 2 ways. You can line them up like I did here, or you don't have to line it up. You can just do it in your head, just add up the like terms. So if you guys can try this example right here, try number 5, this one here. Just combine like terms. See if you can do this one. Line them up. We'll do the subtracting in a little bit. I'm gonna show you how to do the subtracting. Okay, so guys, at any point you have any questions, let me know. So when I look at like terms, I'll notice that this one right here doesn't have anything on the right. There's nothing here that you can combine with. So you just bring it down. So the 3a does not, 3a squared does not have any like terms because of the a squared. You're looking for the variables. I look at the 3ab, I can combine this one with this one. So you just add the coefficients. 3 plus 4 gives you 7ab. That crosses out. And then lastly, you can't combine the negative b squared with the 6b squared. Put a 1 in front of the b. So you would just do negative 1 plus 6b squared, which gives you plus 5b squared. And that's how you do that. Okay. So again, your goal is you look at the variables. If they have like variables, you add or subtract the coefficients. That's the main idea. Constants go with constants, obviously, so on and so on. And I do need to finish probably with the hardest part. That's the subtracting. But we're going to make it easy with the subtracting, but we'll finish with that here in just a little bit. If you need to copy that down or take a picture, do that now before I move on. Okay, so when you subtract, let's make this easy. So when you subtract, I want to do it this way. So look at, we're going to go back to example 2 right here. Subtracting causes kind of an issue. So when you subtract, you have to change the signs of the second polynomial. So what we're going to do is we're going to do what's called adding the opposite. So you have to change the signs of all the terms in the second polynomial. So in this polynomial right here, the second one, anytime you subtract, you have to change the signs of the second polynomial. So we're going to do what's called adding the opposite. So what does that mean? That means that you leave the first polynomial alone. You don't change it. You leave it alone. On the second one, you're going to change the signs, but you're going to add the opposite. You're going to change this sign in the middle from subtraction to addition, and then we're going to add the opposite. So I'm going to change all the signs inside of here to the opposite sign. So this becomes negative x squared plus 4x minus 1. Everybody see what I did? You want to change the signs of those three terms. And you change the minus to add. So again, you're going to add the opposite. You change only the second polynomial, not the first one. Everybody good with that? So what I'm going to do now is just do what we did before. You're going to combine like terms. This term right here goes with this one right here. You can combine this x with the 4x, and then you can combine the constant with the constant. That's going to be our plan. So if I do the first one, if I do 2x squared plus or just minus x squared, this is a 1 in the front, remember? So it's just 2 minus 1, basically, which is just x squared. I like to cross them out as I use them. And now I'm going to combine the second arrows. right? So x squared plus, x plus 4x. Put a 1 in front of here. So it's just 1 plus 5. So it's just 5x. Cross them out. And then on the last one, we're just going to do -4 plus -1. -4 plus -1 is just -5. Done. So again, when you subtract, you add the opposite. I don't like doing it this way when you're doing it. I just like to just do it here manually. So try this one here. You'll change the minus to a plus and then change all the signs of the second polynomial and then combine like terms. Try that one. Yeah, guys, if you don't have a printer, you're more than welcome to make side notes and write down what you need to at home. I know not everybody has paper copies. Most of Algebra 2 can be done on a journal, but I would recommend that you have a journal of some sort, a spiral, a composition notebook. So to finish off with the last one, you bring down the first polynomial doesn't change. The second polynomial, we change the signs, but remember, first you change this, add the opposite, so the minus becomes positive. Now I'm going to change the signs of all three terms inside the second polynomial. -2y squared plus 4y minus 3. And now just combine like terms. So you're going to combine these two, and then the last one. And then that's it. So if I do the one in green, 5y squared plus -2y squared is just 3y squared. Cross it out. Now I'm going to do the one in different colors, the 7y and 4y. You add those, that becomes 11y. Cross that out. And then finally, the one in purple, 8 minus 3, it's just 5. That's it. They might look a little bit more complex when you go to Delta Math, but it's the same idea, same concept. Okay. All right, so your assignment for today is already up. If you do not want you guys have already noticed that there's a late penalty that's not due on time. It is due on Wednesday. It is due, I think it's called Intro to Polynomials in Delta Math. You guys can work on that. And then if you missed or you'd like to watch the recording or went too fast, I'll post that later today with the notes. But again, I'll be here if you have any questions. You guys can work on today's assignment. Again, I will update y'all's test grades. I will put those in today.